Now we are going to see about feedback amplifiers. Okay, what is an amplifier? An amplifier is an electronic circuit which amplifies the signal. The amplifier can be a voltage amplifier or a current amplifier. Why do we go for feedback? In order to increase the gain of the amplifiers, we go for feedback amplifiers. Feedback amplifiers, we have various types. We have series feedback and shunt feedback. Here we are going to see voltage amplifier. So in the voltage amplifier we have series type called voltage series amplifier or shunt type called voltage shunt amplifier. We have with the feedback and we have without feedback. First of all, we see the voltage amplifier without the feedback. We are going to calculate the frequency response and calculate the bandwidth obtained for this circuit. So the required components for these circuits we are going to use 1.5 kilo ohm, 3 kilo ohm, 2.1 kilo ohm, 4.7 kilo ohm resistors, 10 microfarad capacitor, 22 microfarad capacitor, transistor BC107 and 1 microfarad. So we are going to give the connection in the breadboard. First we are going to connect the transistor. Keep the knob facing your side. From the projection, keep it as emitter, base, collector. So this is emitter, base, collector. Emitter, base, collector. Now let us first give the emitter connection first. Connect 1 kilo ohm to the emitter and connect it to ground. Take a 50 microfarad going to connect the capacitors in parallel. Capacitors have connected. Connect the negative of the supply to the ground terminal. Now let us connect the collector part, 3 kilo ohm. Connect it to the other end. As I have only 1.5 kilo ohm, I'm going to connect two resistors in parallel. Connect the supply to the collector. Connect 30 microfarad to the collector terminal. Now connect the base from the supply. We have to connect 5 kilo ohm to the base. From the base we have to connect 1.5 kilo ohm to ground. From the base we have to connect 66 microfarad. Now we have to connect 1.5 kilo ohm to the other end of 1.5 kilo ohm. We have to connect the function generator. This is the function generator. So I'm going to keep it as a sine wave. Keep it as 1000 hertz. The negative terminal ground the negative terminal. Connect the other end of the resistor to the positive terminal of function generator. Now the connections are over. We are going to see the output in the CRO. Connect the CRO. Connect the CRO negative to ground and the positive to the output of capacitor. Set the DC power supply to 10 volt and in the function generator, let me start the calculations from 5 hertz. Move to the next range. So let me keep this as 5 hertz. So for 5 hertz, now we have to take the voltage and the time. So for the frequency 5 hertz output, let me take it as zero point 0.2 into voltage is 1 here. 1. Same way, vary the frequency range. Take another value to 50 hertz. Increase the frequency range. Keep it to 50 hertz. So for 50, the value, see the number of boxes, you can count the number of boxes. In between you can take various values like 10, 15, 20, 25. For 50 you have 1, 2, 3, 4. 4 number of boxes into 0.6. So 4.6 into here 1. Now increase the value of frequency. Take for 100 hertz. For 100 hertz, value is how many number of boxes you get? 1, 2, 3, 1, 2, 3, 4, 5, 5.4. 5.4 into 1. Increase the value. Now increase the frequency to 1000 hertz. So even if I increase to 1000 hertz, for 1000 hertz, my value moves around to 1, 2, 3, 4, 5, 6, 6.4. Into 1. Still more increase the frequency. Move it to the next range. Keep it as 5000 hertz. Now the value is maintained as constant. Okay, so for 5000, the value is still 6.4. Now we have to check till which value we are getting this 6.4. Let me increase this. So as I increase my value to 80k, so as I increase this value to 80 kilohertz, my value, if I increase from this value, see the amplitude decreases. So till 80 kilohertz, my value is 6.4, and afterwards I have to increase the value of frequency. So see here for 224 kilohertz, this value is decreased to how many number of boxes? 1, 2, 3, 4, 5, 5.4. 5.4. So still more, if I increase my value of the frequency, the amplitude still more decreases. So this is the output of the frequency response of an voltage amplifier. So at first, if you plot a graph for frequency versus voltage graph, the value starts to increase at some particular time. It maintains constant and gradually the values decreased. Consider this in dB and this is hertz. So for the same circuit, I can even give a feedback and do the same process. So this is voltage amplifier. Thank you.